Hello folks, this is Mr. Ege, and I'm going to just demonstrate how to design this whistle. And the name of the project is called Emergency Whistle, and there are also some written parts available in the Schoology if you want to take a look at it. But probably this video will be enough for you, all of them. And the whistle is going to more or less look like that, okay? You can modify it, you could make some small changes, perhaps, and I don't want you to invent the whistle, hundreds of years of old whistle, but you can design it a little bit differently. However, I strongly suggest you, as in most of the engineering assignments, original design is essential, and so we're gonna make it pretty much look like this with particular whistle. Let me explain how we're going to do this. First of all, it's going to be part number one, several parts made out of several parts. Part number one is going to be cap part. The body, okay, is this highlighted part, okay, will fit to the cap. The cap is a projection that fits into the depression inside the body, okay, and maybe it's going to be glued or adhesive will be used, okay, later on. And this is the second part. The body part is the second part. First, we're going to create the cap. And the third, we're going to create the bead inside, which is a sphere, okay, with diameter of perhaps 0.2 inches. And finally, the third part is going to be the handle part, okay, with the hole, and for a cord to pass through, maybe if you want to connect, or somebody, user wants to connect. And ultimately, you can literally write your own name, or mom's or dad's name, or teacher's name, whoever, here. And I call this whistler, so I wrote an extruded. It's a depression extrusion, whistler, okay? I named the whistle as a whistler, but you can have the school name, Fairfax High School, or you can just simply company name, your last name, and so on. All right? Okay, so let's start it. Okay, and we're going to have 1, 2, 3, 4, 5 drawings. The fifth drawing is going to be assembly drawing, and 4 drawings will be the part drawings. Okay, so please start your inventor and move your cursor over the file, click on the new button, select the English units and standard IPT in inches. Okay, it's always important, okay, to check the facts. So I usually go to tools just in case, all right, to make sure that my units are inches still, even though I choose the right one. Go to document settings, go to units, and find out it's inches and the pounds and masses and so on. Angles are in degrees, okay? A number of the things also you can check it out. Material generic. For example, you can select stainless steel. It's a good start. So stainless steel is a good material, and apply it, okay? There are a number of other things you can do. Tolerances, for example. Tolerance is 1/32 of an inch. Use standard tolerancing values and apply, and okay. What's the tolerancing? There's going to be at least one semester course in engineering school, if you go to engineering school, about dimensioning and tolerancing, and it's called exactly that, dimensioning and tolerancing. And you learn a lot about parts that are fitting together. It's fun and interesting and very useful class. I suggest you take it, and I'm going to explain a little bit about dimensioning and tolerancing as the opportunity arises, but this is not going to replace a college course, okay? There's a lot more to learn. Dimensioning and tolerancing is literally one of the biggest branches of engineering in any kind of engineering design. There are federal, state tolerances and governing federal tolerances, US tolerances, European tolerances, international dimensioning standards. And there are literally close to 100 volumes of books on this, okay? And not that anybody has to learn about, memorize it or anything, just that there's so much study has been made on dimensioning, standardization of the dimensions and so on. Okay, so I started the new part drawing. Here's my new part drawing. And I want to start with the front view, okay? And I go to origin, and I'm choosing XY plane. I'm sorry, YZ plane, the one on the top, YZ plane, and select the create a sketch, okay? So the create sketch is created. Now I'm going to draw a rectangle. Now what is the rectangle for? I want you to ask those questions to me because it's so important. What is the rectangle? Rectangle is going to be a support drawing. It's a support line. It provides me 4 lines to enable me to construct rest of the lines accurately. So it's called scaffolding in a construction. You need another construction for a construction to happen. It's called scaffolding. Or in a drawing, it's some kind of a construction in a manufacturing drawing such as this one. You need extra support lines. You need a construction lines, not the real actual object lines, but the construction lines to build the object lines accurately. So that's what the rectangle is for, okay? So the dimension of the rectangle is going to be matching the length and width dimension of the whistle, all right? So as long as I want this to be 1.625, but height, I want it to be 0.8, so I'm typing 0.8, okay? Pressing Tab key, that highlights the length of the rectangle, 1.625, so I'm typing 1.625. And I appreciate Inventor because of it highlights and it demonstrates what reminds me what to do. Okay, so I enter the numbers and everything. And I need one more construction line because I need to draw a circle and the center of the circle has to be established. So I need to select the line command, find the center point of the right side of the rectangle and try to hold steady the end of the line as much as possible, perfectly horizontal. The line has to be perfectly horizontal, and that's going to be half of 0.8 or 0.4. I'm typing 0.4, enter. Okay. And why did I do that? Because I need to draw a circle from the end of this line, and circle command. You choose end of the line, click, start your chart, and then you choose the right end of the line, click. Okay. So this is very important part, and this part is exactly fits everything I need. So certain lines I don't need it. So I'm going to hit escape key to get out of the circle command. Now I'm selecting lines. I'm selecting lines to delete them. I don't need the left vertical line. I don't need the bottom vertical line. I don't need the right vertical line. I don't need even dimension. It's dimension either. Not even the construction line I need. I'm just erase lines. And I don't need this extension. But first, before I erase this line, I need to erase the dimension. Okay, so I erase the dimension. And I'm going to trim the end of the line, extension of the line. Okay. And now I'm going to offset the 0.1 inch of the line. So this line will be offsetted, okay, 0.1, enter, enter. So the last line will be also 0.1 inches, enter. And the last line, one more time, I'm offsetting 3 times, 0.1, enter. Okay, escape. So far, so good. As you realize, I'm trying to create the cap, and the cap has some protrusions and some projections as well, protrusions and depressions. Okay, so I'm trying to visualize it. I'm forcing my imagination, my mind to visualize it. So I need another offset. This time I'm circling, offsetting the circle 0.1 inches. Okay? All right. What else do I need? I need a line cap line between end of this here on the vertical line on the left. Okay. I'm trying to, again, visualizing what is happening. Certain lines has to be trimmed. I imagine this line has to be trimmed. This line has to be trimmed. The circle part of the arc has to be trimmed. Okay, this part will be trimmed. This part will be trimmed. This part will be trimmed. Okay. All right. Looks like I almost have everything, except that sharp ends doesn't look good to me. I'm coming from the engineering background. I'm coming from manufacturing background. I did work with the number of engineers and architects and manufacturers before. So I realized that the sharp corners are not very good. They don't, nobody likes it. Okay, so I'm going to use fillet and develop the habit of creating a fillet. So, for example, this end and this end, maybe there should be more than 0.25 inch radius fillet. Okay. I'm not even sure if this is correct. Did the fillet work properly? Select this item. Okay, now it worked properly. Oops. Control Z. Control Z again. Take it back. Control Z again. I'm taking back. I'm going to change 0.25. Okay, the fillet will be 0.25. And I'm going to use the fillet here and select this item and then select this item. Okay. And I want a new fillet around here, and that should be 0.35. I'm typing 0.35, and I'm choosing this line and this line. Okay, good. Okay, so far so good. I'm almost ready. Okay, and I'm going to, some of the dimensions is in the way, I'm going to just pull them outside. They don't even have to be there anymore, but okay, I can even erase them. And I'm going to draw, knowing ahead of time, I have a pencil drawing in front of me, and this is a huge advantage. I'm looking at my pencil notes. Okay, even a simple design as a whistle, okay, require a lot of little things to remember. And if the drawing gets more complicated, if the design gets bigger and more complicated, you definitely have a lot of pencil drawings. Okay. One of the things I remember some of my engineering friends didn't like is drawing. They do have to draw a lot of lines, but they at the end of the college education they loved it because they did so much, so many of them. They become master of it. So drawing freehand sketches is very important part of the design process. Okay, and what do I need to do? I need to draw a simple line here. I am creating this line, okay, thinking way ahead of what I'm going to do. Right now, it's not useful, but after half an hour, it will be useful. Okay, and this line, okay, we're going to offset this line. About ½ inch. Yes. So I'm going to use the offset command. Okay. Select this line this way, type 0.5. Okay. And maybe you realize there is a hole, a it at the top of the whistle. And that hole, okay, should be about this. Now, I'm going to rotate this line also. That's another thing. And I'm selecting the line, and I'm also selecting the center of the rotation. And yes, now I'm going to change this angle and 145-degree angle. So 90 degree plus part of 135 degrees. So I'm going to type 135, enter. Okay. And done. And I'm going to use extend command to extend it. And then I'm going to use trim command to trim that part. Okay. That's my master sketch. I can start extruding. Okay. And I'm going to finish the sketch and save my work. Okay, as a whistle. Simply whistle. And make sure that I'm going to put my last name or name on it too. Okay. So as soon as I ended up finishing the sketch, I will go to File, Save As. Okay, please go to OneDrive and call, okay, I'm going to call one whistle. And good. Now extrusion can start. Extrusion is going to be critical, okay? Because certain parts I want to extrude only so much. Certain parts I want to extrude even more and at an angle. Okay, so I'm going to go with the 0.1 inch extrusion first, 0.1. And I'm going to choose this part. And this part. Okay? And also this part. Okay. Now I'm going to add a new extrusion. Okay, this is the interior part. And it's going to be 0.2 inches of extrusion in the opposite direction, this way. Not only that, also I'm going to put an angle here, perhaps -3 degrees. Why do I need that? Because the protruding part has to be smaller than the hole. That's the reason for perfect fitting. So -3 degree protrusion will enable me to fit this cap. And okay. All right. Is everybody with me so far? Good. Is it finished? Not yet. Stainless steel. It's all good. And number of things I would like to do. One of them is fillet. No, don't not leave anything, any sharp corners. Especially if somebody's going to put it in their mouth. These are sharp corners. They're very, it's a stainless steel. So use fillet command. Okay. And I'm going to just turn around and try to make this. Okay. I'm going to reduce the 0.125 to 0.1. Okay. I think we have accomplished what we wanted to. Or maybe we can make it a little bit less, 0.09. Okay, this is far better. And okay. All right. Okay, now we can save this. Okay. Now this particular part, okay, is going to be the cap that's going to be fitting inside. Okay. Good. So I suggest you to make one thing before you start the second, okay? And I suggest you to go to original sketch and copy the original sketch. Control C will work for me. Okay. Now, finish the sketch. It's been already saved. You don't need to save it again. Start a new drawing under the file, new, another part drawing. Okay, and in system, create. Okay, and select your YZ plane and Control V. Okay, you need this. And try to keep that in mind that the one part will part into another. Okay? So you just simply earlier, you just simply finished, okay, the left side. And now on the part 3, you're doing the right side. Just look at it, please. This is the left side. And the part 3 will be the right side. Okay? So, and you're going to use exactly the same lines. All right? So, finish the sketch. Just simply go to extrude. This time we're extruding everything one at a time. All right. 0.1 inches extrusion. To the left. Remember, everything will be extruded to the left. Okay? This is one extrusion, 0.1 inches. Now the next extrusion is plus button. Okay? And click on the plus button. And choose between first and second lines, area that is only between first and second lines. That extrusion will be opposite direction. And it's going to be, let me take a look at my dimensions, and 0.75. And, okay, 0.75 and 0.65 is fine, 0.65 inch extrusion. And that's going to be plus. Okay, this is the same extrusion, pretty much. Does it look right to you? About right, yeah, sure. Okay, if that is the case, finish the extrusion. Okay? Yeah, so we can live with this and okay it, click OK button. All right, make sure that the material is stainless steel. Again, because people are going to put their mouth, okay? And so we need to get rid of the sharp corners by using fillet command. And we're going to go 0.09 inch fillet, okay? All right. And this is the point you could say, and okay. I think it's all finished right now. And this part will fit into the next part. Now, what do you save it? To whistle. Okay, this is the second part. So that's why you can call it to whistle. Okay, so you go to File, Save As, and make sure you put your last name or first name, okay, in the OneDrive. Okay. What else is there? One of the interesting things you can do, you can choose the surface, okay, and start, and then you can type anything you like. Fairfax High School, you put your name, your last name, Ege Industries, for example. Or, how do you do that? You go to text, okay, because it's a round surface, maybe you should draw an arc first, and I'm suggesting and drawing an arc. Like that, so that the text will be round, and there's a round text, geometry text, by the way. Okay, when you click on the arc, okay, it's going to give you a chance. Now remember that this distance dimension is very important. 0.01 inch offset is not dark. Comma, maybe we should choose a heavier, maybe Arial or Arial black, a rounded black, okay. And size 0.125 or 1.2 or one, just 0.1. And capital letters, okay. And just simply type something that designates that it belongs to you, designers, for example. Maybe it's too small. I'm not sure. We can check it out. And designer industries. So this is too long. Make it short. Okay, so it didn't turn out to be the way I expected. Double click on it, so see if you can make a modification. It should be inside this area, first of all. So does it work? Positions, there are a number of positions here, okay? And change the direction first. See if it's gonna go, and update. Nope, didn't work. And update again. This time it worked. I selected the second one, direction number 2. But letters are too much into each other, so you need to separate the letters. How do you do that? You need to put this in center. How do you separate the letters? I want to fit the text in a larger. I think this is better. Okay. I think this is better. All right. So you wanna have to try update and everything, and okay. Now, What does it do? Unless you finish the sketch, and then you need to extrude it, and you choose selection, cut extrusion. Make sure that it's 0.05 or something like that. You choose inside the area. Okay. So this is cut extrusion. All right. Okay. There it is. Now the word designers is written on it, or your last name, family name, industries, and so on. So you can save this, okay, as to whistle. Good. What else do we need? Well, we're going to assembly drawing. We're going to use assembly drawing. We need 2 more parts, Mr. Again. Why do you do assembly? I can create 2 more assemblies inside the assembly drawing. That's not a problem. Okay? So assembly drawings also enables me to create new part drawings. So these are small parts and unimportant, important parts, but small parts. So it can be created from inside assembly. Okay, so far so good. I'm saving this one. I'm going to go to File again, create new. This time I'm choosing standard inch .iam, inventor assembly. So I'm choosing this drawing and create. As usual, okay, when you create a new assembly drawing, first thing you do is to place the parts. So I need this part and click here. Good. Escape. I need the cap too. 1 whistle. Place again. And 2 emergency whistle. Nope. I need to call this 1 whistle. Open. Click here. Okay. I'm going to bring the first part again. Okay. Place 2 whistle. I just want to make sure that I have the right part open. Okay. All right. So, is everybody clear on this? Okay. So how do we put together? Think about it for a second. How do we put this together? By carrying by hand? Yes, sure. But this is not the way to do it. Okay. If you want to assemble it within an assembly drawing like this, perhaps the best way to do this, okay, use the joint command. Not constrain, but joint. Constrain is only used for the parts that are supposed to be manufactured according to these exact geometric dimensions. The joint command that gives you a chance to fit the parts, okay, using special geometric features. Okay, so what kind of feature are we looking here? I'm looking for planar feature, okay, and I need to zoom in on the surface. Okay, right here, click on this. And then I'm going to just change the angle. And then I need to choose the center of the arc here. And it did not work for me. I may have to try this. So I'm going to cancel this one, okay, and then try to do it again. Okay, joint and the planar surface it's a rigid, let's see, rigid joint. I choose okay, tip is very important. And now I'm going to choose the opposing part. All right. Well, if it's taking me a few times, it will certainly take you a few times as well. So just be patient. I'm not only selecting the surface, I am also selecting a point on the surface as well. Hey, this time it worked. I have chosen the planar surface and the part perfectly worked. And apply. The planar surface, rigid planar surface, yes. Okay, whistle is not done, and if you try to sound it, it's not going to sound because there is no bead inside. Okay, so for that to happen, we need to create a sphere. Okay, so I'm going to just simply remove, okay, everything pretty much the way it's supposed to be here. All right, and I want to position them the way they are going to be 3D printed. Okay, possible. That's what I'm going to do. And one of the things I like to do the part that the handle, that will work for us. Okay, so one joint worked, Now I want to do the second joint, all right? And this is going to be the planar joint, perhaps. I wonder if I can find the plane. Okay. The planar joint, okay, help me to set it up correctly. The second planar joint, so I use two joints, okay. All right. Okay, one more time. This time it worked. Rigid joint. And I select the protrusion. Okay, and now there is a part that we're going to have handle. Okay, to have the handle, we need to create a new part. So there's a create button on the top left-hand corner. Okay, and let's call this 3 whistle. Okay, and now we need to choose a particular surface, a plane. We choose the plane command. Okay, and I just want to make sure that the plane that we have chosen passes right at the center. Nope, it doesn't. So we're going to have to choose the plane and offset the plane, offset from this plane. Okay, so this is the B plane we're choosing, and we want to offset this plane from where it is. To where it's supposed to be. Okay, so if you choose the plane, now we need to create a sketch out of this. Okay? The work plane needs to be selected first. New sketch from the work plane. Press the right mouse button, create a new sketch. All right, so I'm going to start with an arc command. And draw a single line, and then perhaps we're going to copy the same line. Okay. Now we need to select another arc. And okay, I think we can extrude this part now. Two-way extrusion. and choose extrusion. It's going to be 0.125. Okay. All right, and I'm going to continue in the next class, in the next session. And this video, I'm going to end this video here at this point. And I realize that it's a little bit too long for one class only. And